All right, everybody. Time to shush it up. Bring your eyes up here. Put them in the bowl. That's gross. I saw a comedy show a month ago. Dimitri Martin, he's pretty funny. And one of the jokes that I remembered was he said, it's all fun and games until somebody loses an eye. You've heard that expression, right? And he says, I think it's also fun and games until somebody finds an eye. And then he said, I did not see that coming. And then he said, I guess we could say it's all fun and games as long as the number of eyes doesn't change. Anyway, and I thought, that's pretty fair enough. Yeah. Imagine if you were just messing around and you found an eye on the ground. You'd be like, okay, this is not fun anymore. So, all right, everybody. That's my intro, and I'm sticking to it. But now, let's talk about Notes 6.4, algorithms with arrays. So I think we've talked about this before, but an algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. So it's like a series of steps that you do to get something done. And there's standard and well-worn ways to work with arrays. So we don't have to reinvent the wheel with things. In fact, later in this like January, we're going to learn how to sort an array. And there's three ways that we talk about sorting arrays in this class that you need to recognize. You won't have to code them yourself necessarily, but and that's because people figured out here's a way to sort, and we'll call it a bubble sort. And here's another way to sort. We'll call it an insertion sort, that sort of thing. You don't have to I'm going to start from scratch and figure out how I might sort something. You don't have to do that because people have studied this for decades. All right. So we're not going to have to reinvent the wheel. Here's a list of all the things the College Board wants you to know about algorithms with arrays. The ones that are underlined, we're going to do today. Some of them you've done already, like finding the max or min value, finding the sum or the average or the mode, determining if at least one element in an array has some property, determining if all elements have that same property, accessing all consecutive pairs in a list, determining the presence or absence of duplicate elements, determining how many elements meet a specific criteria, shifting everything in an array to the right or the left, reversing the order of an array, and swapping the contents of two elements. It's not a big deal. Just the ones that are underlined are the 6 that we're going to do. I told you we had six practice things. And we'll walk through these things. Checking for duplicates. So if we're going to check for duplicates in an unsorted array, it's easier if it's sorted. You can just check, is the thing right to my right the same as the one I'm on? But that assumes that they're sorted. But if you have an unsorted array, you need to use 2 loops. So yeah, for loop inside of a for loop. And often it will look like this. So in this code here, I've got an array. I say it's initialized with valid data. I made a variable called found dupe, and I set it to false. And then we have 2 for loops. The first one starts at 0 and goes all the way to the end. The second one starts at the next element. So not at the one we were on, and it also goes to the end. And then it just checks, hey, if I find 2 that are the same, like starting at element 0, here's one I'm going to check. Then I start at element 1 and I go all the way to the end. If I find one that's the same as element 0, I found a duplicate. And it sets this variable to true. It still completes all the checking, goes through everything. And at the very end, my code just prints out the value of that variable just because I wanted to show you that happened. You have to check the value of that variable after the loop. This is called a flag variable. When you set up some variable, set it to a particular value, then you do a whole bunch of stuff, and then you could check the value of that variable at the end and say, is it still true or is it false now? Or in this case, is it still false or is it true now? So This code would run, and if there was a duplicate anywhere in the array, it would report it at the end. I mean, it would just say true. Yes?
So the second for loop is going through everything that started from the first one, and the first one goes to the next one, and then it goes through and checks everything?
Yeah, you can't check the whole array. Like, let's say you're on element 5. You can't start at element 0 and say, do I find one that's equal to element 5? Because you would pass element 5 and you'd find a duplicate, which is not true, right? You can't say it's dupe with itself. So when you're on element 5, you check from 6 to the end to see is there any that it's the same as element 5. And then, then you just move to element 6 and check from 7 to the end. That's why the inner one starts at I plus 1. So whatever I is, we start at the next one, go to the end. Yeah.
What does it do if there's 2 different duplicates?
This code just found dupe would already be true, and so it would still be true. It doesn't. And notice this doesn't say if it's a dupe, found is true, else false, because that wouldn't. We set this thing to false in the beginning, just as like a little flag. It's kind of like a flag on a play with football. The flag gets thrown. It doesn't matter if 5 flags got thrown, but either a flag got thrown or not. Either there's some sort of issue going on or not. And in this case, we set it to false, meaning no flags were thrown. And then if a flag gets thrown here, then we know at the end at least one flag got thrown. Yes, Eli.
You set found to 0 and then add the found plus 1.
Yeah. You could make it an int instead and set it to 0, and then every time you found a dupe, you could add 1 to it, and then you could say, I found this many duplicates.
It's the exact same except for...
Yeah, it's just not a Boolean. Yeah, question in the back, someone? I mentioned this found dupe, I'm calling it a flag variable, and it's just one way to do certain algorithms. We already talked about it. If you're in a method, so that code wasn't in a method, that was just code inline. If you're in a method, so right here I've got public static Boolean dupe checker, it gets sent an array called R, and then it does the same stuff, but instead of having to use a flag variable, all I got to do is return the value true if I find a duplicate. If it's in a method, you just like, hey, tell me if there's just one duplicate in here. As soon as you say return true, it stops executing that method code, and the code that called it knows that there's at least one duplicate. And if it gets through all the loop without having returned true, then we have to return false. Because there has to be some way to get out of the method. You can't just say, I'm going to go to that method forever. So we return true if we found a duplicate, and then we return false if we do all that looping and there's no duplicate. Reversing the order of an array. There's different ways to do this. I think the easiest way is to make another array that's the same size, and then put everything from the first array into the other array in reverse order. So that's what I did here. Here's a method. I call it reverse array. It receives a string array called data, and I make a new one called temp, and it's the same length as data. It's a new string array data.length. And then I do a for loop where we go through the whole first original data, and I say, hey, temp I, so in this case that's 0, equals data, the length of data minus 1 minus I. Why do I do minus 1? Because remember, if it's 7 element array, the last element is element 6. So in this case, I would say element 0 is equal to 7 minus 1 is 6 minus 0. So I'd make element 0 of the new array equal to element 6 of the old array. And then as I got bigger, it would work its way across. Questions? And then at the end, I'm returning the temporary array. I'm just sending it back. Hey, there you go. That's the one that's reversed. Yeah, the magic is on the highlighted line, which I already discussed. It's the for loop's going from 0 to 1 less than the length, and I'm filling up the temp array from 0 all the way to the end, but I'm accessing from the end all the way down the beginning in data by using the length of data minus 1 minus I. You'd find out quickly if you didn't do that minus 1, then the very first one would be, it'd get out of bounds because data.length, there isn't an element at that spot. So you have to subtract 1 to get in the right range. You'll have all this. And I guess I thought at one point in my life that this was helpful, but I don't want to waste time. You can look at it and stare and just go, oh my gosh, what did he do? I drew arrows to show you where the data was going, but I don't know. If I could turn back time, I would just delete that slide. Here's the same process, not using a method. I know, but I can't turn back time. It's done. The bytes of data were used forever.
You could delete it now.
It's too late.
It's not. It's not too late.
No, it's already somewhere in some Google machine. It's on the computer. I don't know what you're talking about.
It's in the Google machine.
Here's the same thing, not using a method. We're given one called data. I make a temp array that's the same size, and I do that same magic. And at the end, I say data equals temp. I'm just like, fine. I'm replacing the one that we started with this temp one. And it reverses it. Here's the same thing, not using a temporary array. Now this is kind of nuts. This code swaps the elements one element at a time. Last element to first, second to last to the second, and so on. Key to this working is only looping through half the data, because if you loop through all the data, you spend half the data reversing everything, and you spend the second half putting everything back where it was. I swear to God, when I first learned Java, there was this online course I was doing, and they had an assignment to reverse an array, and I was like, I know I'm doing this right, but they're telling me the test fails. And I finally figured out that I had done the loop across the whole thing. Because I'm like, look, I even put little debugs in that were printing. I'm like, yeah, I'm reversing. And then I'm like, wait a minute, it's unreversing. And then at the end, it was back to its original state. So I'm talking about this data.length divided by 2. If you go through half the array and then literally just swap them. And the way we're swapping is I'm making a temp variable to hold data sub I. And then I replace data sub I with the one from the end. And then I replace the one from the end with the temp variable. And so that can do it without it's nifty, without making a temp variable. But I don't care how you do it. Everybody, let's make sure your noses are covered. Thanks. This is accessing all consecutive pairs of elements. We've done this kind of thing before. I almost didn't put this slide in, but this morning I was subbing for a class and they weren't making me doing anything. So I wrote up 2 slides to show you this. Notice I'm starting at element 1 instead of 0 because I'm down here saying, hey, if these two are the same, print duplicate found. And this is the I minus 1 means if I started at 0 here and then I did a -1, it would crash out of bounds. And this is assuming the elements are sorted. And I mean, in this case, I was just reporting if duplicates are next to each other in an array. Here it is starting at 0. If it bothered you to start at 1, yeah, you can start at 0. But then you have to go I less than data.length -1 because we're doing a +1 over here instead of a -1. And you have to stop 1 early or you go off the end of the array. So anyway, all this will be in the slide deck that you'll have in your queue on the Google in just a minute. So what's left is finish the Pi class and then do A, B, C, D, E, and F. I made videos that help you with all that, but I don't post them for like 45 minutes because I want you to struggle, not copy. And I want you to ask me for help. Ask your neighbors for help. Do the best you can. Remember, if you're struggling, watch some of those AP Classroom videos. Also, you could do some of those coding bat problems again. You can either not log in and do them again, or you could go in and delete your answer real quick and then do them again. Not a big deal. All right, I think I'm going to stop the recording somehow. Here we go.